So hello everyone, welcome back to the channel and you're watching Komal Taya. So guys, in the last video I discussed some questions. In the last videos basically I discussed some questions where figure was given, and in the very latest video, if I talk about more precisely, figure was given and perturbed part was shown in the figure only, and you needed to find out the energy correction, the same old concept. But today I'm going to introduce one new concept, which is Dirac delta function, right? So that is very important concept when it comes to first order perturbation. If the examiner wants to deviate the question, he'll certainly introduce this delta concept in the question. A lot of people don't know about this, and it's very simple, very simple. The only thing is that you should know the tricks, right? So I think without delaying I should start the video. So let's see what this concept has. So basically, so look, this is you can see the page over here, the slide. So it is if perturbed part, can you see what is written over here? That if perturbed part of Hamiltonian is in the form of Dirac delta function. I'll be telling you what will be the Dirac delta function. Means if it is in form of this delta x minus L, like you must have heard about this thing, x minus L or x minus A. You must have seen those things in first order perturbation questions, right? And a lot of you will be like confused at how to solve this question, these type of question. Guys, it's very simple question, just pay attention to it. So if something like that comes, like earlier what we were studying like perturbed part, like the perturbed part is in the form of V or delta x cube or something like that, right? So we were studying it in that form, but now the perturbed part will be in this form. So how to solve that type of question? So guys, whenever delta will come in the question, so the whole, you can see the mathematical operation of Dirac delta function decides or determines the energy correction because of first order perturbation. Fine. So this delta will, if this delta is given in the form of perturbation in the question, right? So this delta will be determining the energy correction because of first order perturbation. Fine. So these lines will be sounding very complicated to you, but I'll be illustrating it so it will be more clear to you, right guys? So basically, suppose the function is in this form, this example, right? So suppose minus infinity to plus infinity, like that, and then fx, some function. You can see the wave function, any wave function of particle in 1D or SHO, anything, right? Hydrogen atom, anything. So, and if delta x minus A, this is the perturbed part is given, and then dx. Fine. So what will you do? Whatever part will be given, just ignore everything, just focus on delta part, just focus on the perturbed part and take that value which is apart from delta. Look, suppose like this is the basic wave function, and this is the things which you are already familiar with. This is the very strange thing which you must not be knowing about it. So just leave delta and put everything equal to 0. So if I leave delta, so anything will be like, suppose in this equation, if I leave delta, so the x minus A is left. So what I'll do, I'll put it equal to 0. X minus A is equal to 0, and I will find out the value of x, that would be equal to A. So okay, now I know the value of x, that is A, right? So what will I do now? I'll put the value of x in all the wave function which is given. So let's take one example. I know this is very this must be sounding complicated. So let's see, I'm taking this example, right? So integration 0 to L, length box is there. Fine. So like if perturbation is given, so you will write it like this only, no? Psi 1 and the perturbed part, like energy correction, if you have to find out, so that would be like 1 and 1. So that would be psi 1 dx, like that. If you have to find between 0 to L, clear. So what will be psi 1 for 0 to L? You know the wave function for 0 to L box is root 2 by L sine n pi x by L, like that, clear. But suppose if I put like this, suppose if I take only sine pi x by L, anything, I'm just taking imaginary, although it should be root 2 by L, like that. But if I'm taking sine pi x by L, clear. So I have taken psi like this, sine pi x by L, clear. So this is just one example, guys. So it will be mentioned, you will be knowing what will be the wave function. So I have taken this one. Clear? Suppose this is the perturbed value which examiner has given, that this the perturbed part is like this, that perturbed part is given like this, and you have to find the energy correction now. Like now find energy correction in the ground state, and first order energy correction. Fine. So what you will do, you will put the wave function like this. This is psi 1, this is perturbed part, and this is psi 1, and this is dx. Clear? Suppose the wave function is also given like this. Like if examiner is saying the wave function is this, sine pi x by L, so you will take like that, and then you will put the value. Simply you are putting the value. Clear? So what will happen now? What did I tell you just now? That just leave everything. Leave everything. How to solve this integration? That apart from delta, whatever will be there in bracket, just put it equal to 0. That is x minus L by 4. That is in bracket. So just put it equal to 0, and it would be x is equal to L by 4. And now you got the value of x, that is L by 4. Clear? So you got the value of x, that is L by 4. So what you will do, let me just rub it first so things get more clear to you, because I need to write it over here. So now what will happen, you will put the value of x in this equation. So let's see how you will put. You will just forget about this thing now. You will forget about this thing now. And integration, you will remove the integration now. You will forget about this thing now. So whatever things will be there apart from this, you will be putting the value of x there. So you will put the value of x here and here. Clear? So you are removing integration, so dx will also be removed. Guys, this is the method to solve the question, and this is a trick to solve the question. Clear? So because it will be determined by delta. Fine. And this is the method that how it will be determined. Simply you will neglect the thing apart from delta. Fine. And you'll put it equal to 0, and the whatever value you'll get, like you'll get L by 4, and you'll put that value in these equations, like in the wave functions. Clear? So that is apart from this value, basically. Apart from perturbed value, you'll put the values there, and you'll remove the integration. Remove the integration, neglect the delta part, and put the value of x, which is L by 4, in this. So what will happen? Sine pi by L into x. So what is the value of x? That would be L by 4 into one more sign is there. So you will put sine into pi by L into x. So x is again L by 4. So you will put L by 4. Clear? So what will happen now? L and L will get cancelled out again. This and L and L will get cancelled out. Clear? So the remaining values are sine pi by 4 and into sine pi by 4. So when you will be putting the value of this sine pi by 4, it would be 1 by root 2, and again sine pi by 4, it is 1 by root 2, and when you will multiply it, you will get the value 1 by 2, and this is the energy correction in the ground state, the first order energy correction, that is 1 by 2. Fine, and this is the answer. So guys, this is how you have to solve the question. Again, I'm repeating this. Take the delta part, fine, whatever is given apart from delta, put it equal to 0, just find out the value of x and put that value of x. Suppose here I found out the value of x by putting it equal to 0. So I found out the value of x, then put this value in this equation, but before that you have to remove the integration, like the ds and integration and this delta part, and you will be putting the value in everything which is left now. Clear? I hope that is clear to you. So I'll be taking more examples in the coming videos, right guys? So there the things will be more clear to you when I'll be taking the proper example and proper previous year question based on it. And this concept is very important. You cannot afford to miss on this topic, and the Dirac delta function is seriously very important question which you can expect in exam. In fact, the everything about approximation system which I have been telling since 10-15 lectures, it's very important. Like after the superposition principle, the second part of quantum, it becomes very, very important. Every topic is so important that you cannot even miss even a single topic. Like the Dirac delta, it's a very small part of perturbation, and perturbation is small part of approximation system, right? So so like if you miss out on this, suppose if question comes from this delta thing, so you'll be very confused at how to do it. So do not miss any part, right? And be with me. I'll be covering everything about quantum, and you'll not be complaining to me that you have missed out on those topics. Clear? So I think that's about it, and that's about this lecture. So I hope you liked the lecture, and please feel free to comment down your queries. You can also join my Telegram group. The link will be given in the description box only, right? So that's it for this one.